ado, let's just go straight into solving this. Having laid the foundation required to solving it. Alright, required to solve it rather. Now, when you look at this, you realize we have let's giving us this. We have your SO2. That's always the first thing. We are not wasting time on this, like I said. Now, how do we know which one is oxidation, which one is reduction? Simply put, check the oxidation number for chlorine here. Yeah, the oxidation number, oxidation states could be said to be what? -1. But when you look at it here, it is simply 5. How do I know it is 5? -2 multiplied by 3, that's -6. This is going to be -6 equal to -1 plus chlorine. Alright, when this one comes here, it becomes 6 minus 1. So we are sure that is 5. Now, you know how to calculate that. Calculate it on your own. So we are sure that because the oxidation number of chlorine has reduced here, from 5 to -1, we are sure reduction. This is our reduction. And this is our oxidation. So we have done the first thing required of us. We have broken it into half cells. The next thing is balance charge and atoms. Now let's look at charge here. Now you can see we have oxygen here. Do we have oxygen here? No. Alright, how do you balance oxygen on the deficient side, like I told you earlier? So you are going to balance an oxygen with 1 water on the deficient side. So you are going to have your balance. It's going to be ClO 3 minus Cl minus plus 3H2. Alright, in the bit to balancing oxygen atom, you have added hydrogen. So balance the hydrogen also on the deficient side, and that will be plus 6 plus. And let's just do everything necessary with this and go into the second half cell. Alright, now let's look at the electron. What do you have here? You have a negative charge, 6 positive charge, a negative charge here. So this one is by how many by what amount of charge greater than this? That's by 6 positive charge. Then how do you negate the effect? You negate the effect by simply adding the number of electron required, and the number of electron required here is simply going to be what? Now if this is negative, cancel that, positive 6, then how do you negate that? Now what you do is just put your 6 electron here. When you do that, you are done with this. Now let's look at the second half cell. Then we have our, now the second half cell, this is the first half cell. The second half cell is SO2, sulfur 4 oxide, given our sulfate ion. Now you realize that one side is having oxygen more than the other. This side, with how many atoms of oxygen is it greater than this? 2. Then you add 2 water to this side. Now, how do you balance the hydrogen? Because you have added 4 hydrogen atoms here, you balance it with 4 ion. I believe we are together. Alright, so now the next thing is you just look at the charge and balance of the charge. Now when you balance of the charge, what do you have? You have your -2 here, you have your +4 here. Now you don't have any charge here. It means this side is having the net charge of +2. So you have to look for a way of now equating both sides in terms of charge. So what do you do is, because it is having 2, that is +2 as its net charge, add 2 electrons to make it equal to this side in terms of charge, and by that you are done with balancing charge and atom. Now the next thing is you balance the electron. Now let's look at the electron. How do you balance the electron? You realize that this side is having 6 electrons. I mean this first half cell, while the other one is having 2 electrons. So the simple thing you have to do is you have to multiply this equation by 1, and you multiply this by what? What are you going to multiply with 2 to give you 6? And that's simply 3. Then you are good to go. So that's basically what balancing equation and redox reaction require of you. So after that we have done the multiplication, we have our ClO3 minus plus 6H plus 6 electron, giving us Cl minus plus 3H2O. That's the first one. While the second one will be 6H2O, having multiplied this by 3 plus 3 SO2, giving us 3SO4 2 minus plus 12 hydrogen ion plus 6 electron. Fantastic. The next thing you have to do is you add up the equations. Yeah, I didn't include that. Add up both equation. In fact, this is going to be the same step you are going to follow when we get to basic medium. Alright, so when you add up equation, when you add up A and B together, what do you have? Now, before you add up, just look at it. You can realize that, okay, let's just add it up. I was trying to say that you can equally cancel the electron even before adding it up. But I think it will be better for us to add it up before we cancel out the electron. I think it will be better then. You could see it very clearly yourself. Alright, we are going to, when you add it up, this is what you are going to have. Let me put it here. Plus 6E plus 6 H2O plus 3 SO2, giving you your Cl minus plus your 3 H2O plus 3 SO4 2 minus plus 12 hydrogen ion and plus a 6 electron. Now, electron on both sides, cancel them out. Now, do you have water here? Yes. On the product side, do you have water on the reactant side? Yes, rather. Alright, we have 6 mole of water here, we have 3 here. When you subtract these 3 from the, you are going to have 3 left here, and nothing is going to be here again. You are going to do that as well. When you look at this, you can realize you have 12 hydrogen ion here, you have 6 hydrogen ion here. So when 6 is out here, nothing is left here. When 6 is taken away from this, you have 6 left. So the next balanced equation of reaction we are required to provide will therefore be, after that we have remove this, you're having 6H plus left, and you're having 3H2O left. So you are going to have your you are going to have ClO 3 minus plus 3H2O plus 3 SO2, giving us Cl minus plus 3 SO4 2 minus plus 6 hydrogen ion. And when you look at this, you realize it's balanced. You have 6 hydrogen, you have 6 hydrogen. You have a chlorine, you have a chlorine. You have 3 here, 3, 6, 6 plus 6, that's 12 oxygen. And what do you have here? 3 times 4, that's 12. You have 3 sulfur here, you have 3 sulfur here, and this is the equation you are required to provide. It is as simple as that. Now we go into balancing equation of reaction, of, let me just say redox reaction rather, in basic medium. Alright, this is the final answer. I believe you have seen that, so let me just clean it down. Alright, this remains our template here. I mean the steps I have included here. Alright, now the next we are dealing with is in basic medium, like I said, and the first one is Cr 3 plus PRO minus, giving us CRO 4 minus and this in a basic medium. Now this is redox reaction in basic medium. In fact, let me clean this. I believe you should master the steps now without even helping you. Student of good. Alright. So first step, break it into half cells. You have your, this is the first step. That's the first step. Step 2 is balance in terms of charge and atom. Now when you want to balance in terms of charge and atom, this is basic medium. Now in basic medium, one oxygen atom is balanced with 2 hydroxy ion on the deficient side. Now we have your oxygen here. Alright, so this side is going to be the deficient side in this case. This side is going to be the deficient side. Alright, now you have your oxygen here. This is the deficient side in this case. Alright, so how do we do that? Let's take the first one for instance. We want to balance the charge.